Hi, Thiago Alves here. On the previous video, you learned how to install the OpenPLC editor on 3 different platforms. Now, you're going to learn how to install the OpenPLC Runtime. You see, the editor, you can use it to create your PLC programs, but you will need the runtime to execute the programs you created on the editor. Before we jump in, I would just like to mention that this video is only possible because of the love and support of our OpenPLC friends. So if you like this kind of content, please consider going to our Patreon website and becoming a sponsor yourself. So let's start installing OpenPLC Runtime on Windows. As we did with the editor, the first thing you got to do is open up your browser and go to the openplcproject.com website. Then here on the documentation section, you'll be able to learn more about OpenPLC in general and even instructions on how to install the runtime on different platforms. For Windows, here on the documentation, you have basically 2 options. You can download an installer that will take care of everything for you, but in some cases where the installer might not be suitable, for example, if you don't have admin access or there are some restrictions running those type of installers, you can install the runtime manually as well. The manual installation process is more convoluted and requires you to download another software called Cygwin, which is a compatibility layer between Linux and Windows. And after you download this, you just need to follow along with these instructions, type a few commands on terminal, and in the end, you will have the full installation of the runtime running on top of Cygwin. For today, we're just going to focus on the installer because that's the easy part. So you just click on the Runtime for Windows here, Installer. If you see a disclaimer here saying that this file hasn't been downloaded many times, you just click on Keep. That's fine. Show More and Keep anyway. Once it has finished downloading it, you just click on Open File. If Windows nag screen pops up again, just click on More Info and Run anyway. For now, all you have to do is sit back and relax, and the install will take care of everything for you. Once Cygwin installation completes, you will see another window popping up. This is for the actual OpenPLC Runtime installation. Alright, installation has finished. You can safely close this window, and you can even close the browser if you want. You will find the runtime on your Windows menu down here. Just type OpenPLC, and you'll see the entries here. There's a new entry called OpenPLC Runtime. Click on this, and a new window will pop up, right? The runtime is a web server that runs on your own computer. You can access it from other computers as well, but since we're running on Windows, it makes more sense to access it here, right? You won't see anything on this screen. This is just the screen telling you that the runtime is running on the background. To actually see everything that the runtime has to offer, you need to go back to your browser, and then you type the address that is shown here, which in this case is 0.0.0, which means localhost, which is this computer, right? So you just type localhost, comma 8080. Now you see the OpenPLC Runtime login screen. The default username and password for the runtime is OpenPLC, right? See it here. Once you load the runtime, you have a couple options here on the left. As you see with the first installation, the default username and password is OpenPLC. It is wise for you to change that once you log in the first time. All you have to do is click on Users, and then select that user, and you can change the username and password here and even add your email if you want. So I'll put my name, and I'll select another password for me, and I'll save changes. Once I save the changes, it will log me out and it will ask me to log in again, now with my own credentials. Okay, I'm back in, right? So this is the runtime installation for Windows. Let's see how it looks like on Linux. So here I have Fedora again as my Linux distro. To install OpenPLC Runtime on this distribution and any other Linux, let's go ahead and open the browser and check on the documentation. As we did with Windows, just click on Documentation here on the top, and then go to the Installing OpenPLC Runtime on Linux topic. You see that on Linux, it requires you just to type a couple of commands on terminal. So let's do this. I'll click on Activities, Start Terminal. I'll increase the font size a little bit, and I'll follow along with the instructions here. So the first thing is to make sure that I have Git installed. This instruction uses apt-get, which is common on Debian and Ubuntu-based distributions. On Fedora, instead, I have yum. So it's basically the same thing. I just need to type sudo yum install git. Type in my password. And apparently, it's all good. I already have Git installed on this machine, so nothing else I need to do. With Git, I can clone the repository where the OpenPLC runtime is stored. So this is the command to clone it. I'll type it in here. Git clone. All right. So it's cloning the entire runtime, and it's now here on the OpenPLC v3 folder. Okay. So I'll just cd to that folder, and now you will see that there is a install script here for me. If I just run this install script, it will tell me all the options that I have to install the runtime. One of the options is Linux. Since I'm on a regular desktop Linux distribution, I'll use that option. Install Linux. Take note that I'm not running this installer script as root or with sudo privileges. It's just a regular user, and just as with the OpenPLC editor installer, if it needs administrator privileges, it's going to ask you. Once you see this message, it means that the installation has finished successfully. Next step is to run the runtime. On Linux systems, the installer creates a systemd service automatically for you. You can check this with the command systemctl status OpenPLC. So as you see, it's not running. On Fedora, sometimes it will just fail, and that's okay. You can run it manually. On Debian and Ubuntu systems, it usually will just run the first time. For systemd services, sometimes it requires a reboot, which means that once you reboot your system, it will be running on the background every time you boot it. If you want to stop it, you can just do sudo system control stop OpenPLC, and then you do that again, and instead of stop, you say disable. And then it will remove the system, and it will never start up again every time you boot your system, right? But you can leave the system on, the systemd service on, if you want to have OpenPLC running on the background. That's very useful, for example, if you're installing the runtime on a Raspberry Pi board, that you want it to run every time the board boots up, it will be there every time, all right? So to run it manually, you just have to launch this start OpenPLC script here. It is recommended for you to start it as root because the runtime requires privileged access to some components of your system, especially if you're running it on a Raspberry Pi or another board that has GPIO pins. You cannot use those GPIO pins in most cases if you're not root, right? Besides that, on desktop systems as well, if you're running a Modbus server, any server that runs on ports below 1024 requires administrator privileges as well. So we'll just go ahead and run this with sudo. And it's running just like the Windows version. It's running on localhost 8080. I can go to my browser, type localhost, and it's right there. Okay. Again, I can log in with OpenPLC, and I have the same screen, the same runtime here. I can go and change my username as well. Put my name here, put my password, and I will even change the name here. I'll put Thiago Alves. Save changes. Ask me to log in again. And now you can see that it's displaying my name here as the user, right? Let's see a third platform. Since I am on Linux, I'll just connect to that platform from here. I'll get another terminal window. Okay, that's good. Good enough. Make it big. And then I'll just SSH to my Raspberry Pi. It's at 192.168.0.57. I want to connect to that, and then I type in the password, and I'm in. This particular Raspberry Pi is running RetroPie. RetroPie is just a variation of Raspbian. It should work the same. It's the same thing, just that this version is more focused on gaming, as you can see the logo here. I like to play games sometimes, so this is what my Raspberry Pi is running right now. But it doesn't matter. I can run OpenPLC on this as well. The main requirement of OpenPLC on Raspberry Pis is the installation of a library called WiringPi. And this is mandatory. Without this library, you won't be able to control the GPIO pins on your Raspberry Pi. You would even be able to install the runtime and run your programs, but those programs won't control the GPIO pins. So that makes it kind of useless to run OpenPLC on a Raspberry Pi, right? To install WiringPi, you can go to your browser and then download the release version of WiringPi on GitHub. You can just type WiringPi GitHub on Google, and it generally would take you to the right place, which is github.com/wiringpi. Okay, so this is the main project, and there's a lot going on. A couple commits a few months ago, but what matters the most is here on the right, the releases. So you're just going to click on releases, scroll to the bottom, and you will see two files here. You will get the ARM64 version if you have a Raspberry Pi 4 or upper running a 64-bit operating system, right? If you're running on a Raspberry Pi version 3 or under, you're going to pick this one, the ARM hard float version. So this is my case. I have a Pi 3. I just downloaded the Debian file, and it sits here on my downloads folder. I need to transfer that file over to my Pi. There are several ways to do this, but the way I like the most is the good and old SCP. So I'll just CD to my downloads folder, and I'll SCP the WiringPi Debian file to my Raspberry Pi. And I'll put it on the home folder. Just this comma here at the end tells me that this is the home folder. Type in my password again, and I transferred the file. I can see it here now that the file sits on my Raspberry Pi. Now I can install it with dpkg, sudo dpkg-i to install, and I just provide the Debian package that I wanted to install. All right, WiringPi was installed correctly. Now I can proceed with the OpenPLC Runtime installation the same way I did with the Linux version. So I'll clone my repository. All right, then I'll cd to the OpenPLC v3 folder, and I see that there's the installation script here again, just like the Linux version. The only difference is that instead of installing the Linux version, I will install the customized version for the Raspberry Pi. Because the Raspberry Pi runs Linux, you would be able to install the Linux version and it will run, but you won't be able to activate the Raspberry Pi driver to control the GPIO pins. So it's better to just pick the Raspberry Pi version. And all I can have to do is to type install rpi. It is gonna take a while to install the runtime on a Raspberry Pi. It's a slower system than my desktop, so it's gonna take a couple minutes, maybe 10-15 minutes. Just sit back and relax again and wait for it to finish. You'll have a fully working installation of the OpenPLC Runtime on your board. Alright, just as before, we reached the end of the installation process with the compilation finished successfully message. I can check the service here with the system control status command, and I see that the service was installed and loaded, but it's inactive. That's the default state on Debian based systems like Raspbian. So what I can do now is to start the service, reboot the Raspberry Pi, that also will start the service automatically, or launch the runtime by hand like I did with the Fedora version. Well, let me do it a little different then. Now that I have the Raspberry Pi, I'll just start the service using the system control. So just do sudo system control start OpenPLC. And then I can check the status now, and I see that it's running, right? Same as before, it's running on localhost. But then it's running on localhost for the Raspberry Pi. If I'm going to access it from a different machine, which is 99% of the case, right? You don't want to connect a screen to Raspberry Pi every time you need to program it. You'll have to type the Raspberry Pi IP address on your browser. Okay, I know that this Raspberry Pi, I'm already connected to it. I know it is running on the 192.168.0.57 address, right? So I can just go ahead to my browser here, and I'll type in my Raspberry Pi IP address on port 8080. And again, I'm greeted with the OpenPLC login screen. I can log in with OpenPLC, and I'll change my user. And just to be different, I'll say Thiago Alves on the Pi. And I'll put my username and a password. I'll save the changes, and I can log back in. Right? So I've logged in from Linux. I can do the same thing from Windows, right? So here I am at my Windows installation. The Windows runtime is running here on the background, and I can switch to my Raspberry Pi runtime as well on the browser. Just type the Raspberry Pi IP address. Okay. Again, I log in with my user, and I know that I am on the Pi because I have here my username Thiago Alves on the Pi, right? So this is the remote Raspberry Pi OpenPLC runtime running. Now that we are here, I'll use a couple minutes to just lecture a little bit on the functionalities of the OpenPLC runtime. I'll just give a quick example on how to upload a program here and what are the main functionalities. So the runtime is meant to run your PLC programs, right? So this is the main thing you'll see here on the runtime is the programs that were uploaded to your runtime and ready to run. This is the list of the programs. It comes with just one blank program, and you can upload your own just clicking on this button here. Slave devices is used if you want to attach additional I/O points to your runtime. So you have another slave device that has additional analog inputs, analog outputs, or any other kind of I/O, you can add them here. Monitoring is used for you to monitor your program that is currently running. You can see the variables and see the state of the variables. Now on the Pi, there's this important portion here that is the hardware tab. By default, when you install it, it comes with a blank Linux driver, right? You would have to change this if you want OpenPLC Runtime to be able to control the Raspberry Pi GPIO pins. You have what is called the Pi header, right, on the right side of the board with a bunch of pins. Those are the GPIO pins. OpenPLC can control those pins and change their state, turn them on, turn them off, just like a real PLC. So to be able to control those, you'll have to change the driver here to a Raspberry Pi. There is still an older version of this driver for the first Raspberry Pi, the Model B from 2011. I don't know if anyone has this board anymore, but for everyone else that is not running on a 2011 Raspberry Pi model, you just click on Raspberry Pi and click on Save Changes. It will just regenerate the core of the OpenPLC runtime, enabling the Raspberry Pi driver, and it will just finish in a minute. All right, has finished compiling and installing everything. You're good to go. You can go back to your dashboard. And now let's run a program. For me to run a program here, I need to start opening the OpenPLC editor and create my program. Since this is not a tutorial about creating PLC programs, I'll just go on the short path of opening a tutorial. I like the Blink tutorial because it's very simple. We saw this example on the installation of the OpenPLC editor. But just to refresh your memory, I will start a simulation here, and you will see that the Blink example, all it does is to blink an output. Once the runtime starts running, there you go. You see it's blinking the output, right? Every second. So let's have this running on the Pi. The only thing you need to be worried about is if you want to control a pin on your Raspberry Pi, you need to know what is the pin location. For that, let's go back to the documentation on the OpenPLC project website. Then you click on documentation. And on the OpenPLC runtime session, you can see here a tab called physical addressing. Here you'll see a list of all the supported PLCs and platforms on OpenPLC. If you scroll down, it's in alphabetical order. Actually, it's after all the microcontrollers. There you go, you have the Raspberry Pi. Okay, so here are the pin numbers looking at the Raspberry Pi header, right? Here are the pin numbers for all the digital inputs and digital outputs, right? The location is a PLC variable. This is defined on the IC standard, where Q means output and I means input. X is for a digital, either digital input or a digital output. So the first address available is QX0.0, and that corresponds to pin 08 on your Raspberry Pi header. Location QX0.1 is location 10, it's pin 10, and so forth, right? You can go up to QX0.7, that is pin 32. So let's just use pin 08 is the first pin available on my output, and I'll just use, that's the location for that pin, QX0.0. You will notice that for every platform, on all the supported platforms, OpenPLC addressing is the same. It's always on this nomenclature right here, QX0.0, IX0.0. That's the format that is followed for every platform. What is going to change, or what you have to look, is the correspondence between the location and the actual physical pin on your board or PLC, right? So let's move back to our editor. For pin 8, I know that the location is QX0.0. Now, when I upload this program to my Raspberry Pi, I can add an LED to pin 8, and it's gonna blink just like this program. To upload it to the Raspberry Pi, I need to click on this orange download arrow here. Once I click on it, it will just compile the project and allow me to save it somewhere. I'll just save it on desktop, and I'll call it blink.st. All right, now that I saved the program, I will upload it to my Pi. Go back to my browser, click on Programs, make sure that I am connected to the Raspberry Pi. I'll choose a file, and here on desktop, I see my blink.st file. I'll upload that. It asks me to give it a name. I call it Blinky. And for the description, I'll say my first OpenPLC project. And hit upload. All right. Now that it has finished uploading my program, I can go back to the dashboard, and I see here that the program that is loaded is Blinky, right? And if I go to the list of programs, I can see both Blinky and the Blink program right there. Okay. So on the dashboard, I can click on Start PLC to start the runtime, right? To execute my Blinky program. I hit there, and in a minute, I see logs here that the program has started, and it has also started the Modbus server and the DNP3 server, and also the Ethernet IP server. All these three servers are enabled by default when you install the runtime. We're gonna talk about this on a future video. But today, all you have to see is that the Blinky program is running, and I can go and click on monitoring and see it in real time that my blink LED is blinking, right? I'm too lazy to connect it right now, but if I connect an LED to pin 8 on my Raspberry Pi, I would see it blinking together with this blink variable here, right, on monitoring. Now I can do the same thing with Windows and Linux versions as well. So just to prove the concept, I still have the Windows runtime running here in the background. I'll switch to that. Log in with my username. And you see that this is the Windows version, right? It's running on localhost. And I'll just upload the same program to the Windows runtime. You see that the same program is compatible with any OpenPLC runtime, whatever platform it is running. I'll just call it Blinking on Windows. All right, it compiled, and I can go back. If I start my PLC here, it is going to start the Modbus servers, and I can click on monitoring, and I'll again see my blink LED blinking. For obvious reasons, I don't have any GPIO pins on a PC, so I can't connect an LED anywhere here to see an actual LED blinking. But the runtime is actually running your program. It is useful because on Windows you still can add slave devices, right? So in a future video, I'm going to show you how to attach slave devices to OpenPLC runtime. So even on Windows, you can attach some external I/O and see a real LED blinking or any other type of device that you're controlling. Okay, and just to prove the point, I'll do the same thing with the Linux version. So I have Fedora running here. I just don't know the IP address of this box, so I'll figure that out real quick. So I'll just get the IP address for this Fedora box. It's 0.22. I'll go back to my Windows and type 192.0.22.8080. And this is my Linux OpenPLC, right? And again, it has only the Blink program. I will upload the same Blink file that I created previously. I'll say Blinky on Linux and upload that. Compiled, go back to my dashboard, and I hit Start PLC, and I have the same effect, right? I can see on monitoring that my LED is blinking, although again on my Linux box I don't have a physical I/O to control. I cannot attach an LED as opposed to the Raspberry Pi platform. But here is the same program running on 3 different platforms. I see it here that it is running on a blank Linux, right? So it's Fedora. This one is running on blank Windows, that's by default. And this one is running on a Raspberry Pi. Okay? All right. Thank you very much for watching, and don't forget to subscribe and hit the like button.